Hey students, this is lesson 624. In this lesson we are going to learn about parallel and perpendicular lines, and we're going to learn how to represent right equations for parallel and perpendicular lines. Go ahead and do 1 and 2 and read the vocab here. I'll pause for you. Hey students, think about this graph here. It says, can you draw a line that will not intersect either of the lines in the graph? If so, draw the line. If not, why not? And probably, I hope you're thinking that you cannot. And the reason is because it's obvious that these two lines have different slopes. The slope of this line is 2/5, and the slope of this line is 1/3. And in order to be parallel, two lines would have to have the same slope. So the second question says, can you draw a line that will intersect one of the lines in such a way that the intersection forms four congruent angles? And the answer to that is yes. And it just said one of the lines. So let's just draw a line here, and we would just have to put it in such a way that this is a right angle, and we know if that's a right angle, then so would this be, and so would this be, and so would this be, and those are called perpendicular lines. All right, so two distinct lines in a coordinate plane either intersect or are parallel. Parallel lines lie in the same plane and never intersect. So, key concept here, we talked about this before, non-vertical lines are parallel if they have the same slope and different y-intercepts. Vertical lines are parallel if they have different x-intercepts. So draw a line from each equation in column A to the equation whose graph is parallel in column B. I'll let you do that. You can check back for your answer. All right, so we know that parallel lines have to have the same slope. So we're going to use that to help us create equations of lines that are parallel. It says, what is the equation of slope-intercept form of the line that passes through the point 215, and is parallel to the graph of y equals 4x minus 1? Well, the important information we need here is we need the slope to be the same. And we know when it's written in this form that the slope is the number, the coefficient of the x term, which is 4. So we want a slope of 4 to be parallel. And then we just want to pass through this. Now, if you're given a point, the best way to write the equation is just to put it in point-slope form. And that's this one, y minus y1 equals m times the quantity x minus x1. And we know m is 4, so we'll substitute that in. And we know y is 15, so we'll subtract that from y. And then we know x is 2, so we'll subtract that from x. Now, we need this equation to be in slope-intercept form, so we just need to transform it, just solve it for y. Basically, we just need to add 15 to both sides. And now we have y equals, and then I'm just going to simplify it and use the distributive property here, 4x minus 8, and then add 15 to that, and I get minus 8 plus 15 is 4x plus 7. All right, go ahead, you try that. I'll check back with you. All right, the second concept we're going to talk about here is that the slopes of perpendicular lines. Two non-vertical lines are perpendicular if the product of their slopes is -1. Two numbers whose product is -1 are called opposite reciprocals. A vertical line and a horizontal line are also perpendicular. So if the slope of a line is 2, like this one, we want the slope of the line that's perpendicular to that, and that's drawn in here. And notice that the slope of that is -1/2. So I'm going down 1 for every 2 I go over. And that's this answer right here, D. And notice that if I took those two slopes, this slope being up 2/1, 2/1 times -1/2 is equal to -2/2, which is -1. So And in general, we need, in order for two lines to be perpendicular, the slopes need to be opposite reciprocal. Let me give you one more example of that. I'll just draw a line in here. The slope is, say, 2/3 up to over 3. That's about right there. All right, now I'm going to draw a line that is perpendicular to that. And you'll see that the slope of that line is 3/2. Okay, so that's perpendicular. Now if I put that right on a grid somewhere, and then I'll check out the rise and run right there, you'll notice that that slope is, so this slope was up 2/3, and this slope is over 2, so the rise is 2, and it's dropping 3, -3/2. So those two numbers are opposite reciprocals. Their slope is -1. So that's what we're going to use in the next few problems. So are the graphs of 2y equals -3x plus 6 and y equals 2/3 x parallel, perpendicular, or neither? Let's use the slopes to help us here. So we have the slope right here of one of the lines is 2/3. If the slopes are the same, we know they'll be parallel. I'll just write that. If the slopes are opposite reciprocals, we know that they're perpendicular. Otherwise, we'll say they're neither. So let's just solve this other equation for y. Put it in slope-intercept form so we can see what the slope is. So just divide both sides by 2. Then we get y equals -3 x plus 6 divided by 2 is 3. So that slope is -3/2. And 2/3 and -3/2 are opposite reciprocals. What I mean by that is they're flipped over and one is positive, one is negative. You can check that by just multiplying it out. -6/6 equals -1. So you know that these are perpendicular. Okay, I'm going to let you try that. All right, the next thing we're going to do is learn how to write the equation of a line that is perpendicular to another one. Okay, so first thing you want to do is figure out what the slope is. So we're going to look right here, since this is written in slope-intercept form. Our slope is -5, 6. The slope of a line that's perpendicular to that will be the opposite reciprocal. So what I want to do is just flip it over. And since this one is negative, this new one needs to be positive 6/5. So I'm going to eliminate two choices here. We know it's one of these two now. Now it has to go through the point 10, 15. So I'm going to use point slope form and substitute in 15 for y sub 1, -6/5 for the slope, and then I'm going to substitute 10 in for x. And I'm just going to simplify that. 6/5 x minus 12. 6/5 times 10 is 12. And then I'm just going to add 15 to both sides. And -12 plus 15 is 3. So y equals 6/5 x plus 3. And that's my answer. Okay? And you could check that by graphing, but we don't need to do that. All right, you try that. All right, let's solve the problem here using the information we've learned. It says that Carla is using a coordinate grid to make a map of her hometown. She plots Main Street as shown. If 3rd Street is perpendicular to Main Street at 5'7", what is the equation for 3rd Street? So it has to be perpendicular. That means the slope has to be the opposite reciprocal. So let's figure out the slope. Looks like Main Street. It looks like the slope of that is we're dropping 1 for every 5 we go across. So the opposite reciprocal of that, let's flip that over, 5 over 1, make it positive, would be 5. And since we want it to cross at 5, 7, let's just use this form, point slope. And we're going to put 5 in for the slope, and we're going to put in 5 for x of 1, and we're going to put 7 for y. And it says, what is the equation? It doesn't say what form we need, so we can just leave it like that. All right? Go ahead, you try that. All right, that's the end of this lesson. Go ahead and, if you want to try a couple problems, see if you understand it, you may do that. Otherwise, we will talk more about this next time we meet in class.